This section explains the fetch, decode, execute cycle. This is a silver-level explanation. It builds on basic prior knowledge. By the end, you should describe how an instruction is processed. You should also identify the key registers involved. The CPU processes programs one instruction at a time. Each instruction follows the fetch, decode, execute cycle. Fetch is the first stage of the cycle. The program counter stores the address of the next instruction. The address in the program counter is copied to the memory address register, or MAR. The MAR holds the memory address being accessed. That address is sent to main memory. Main memory returns the instruction at that address. The instruction is placed into the memory data register, or MDR. The MDR holds data or instructions from memory. The instruction is then copied into the current instruction register, or CIR. The CIR stores the current instruction being processed. The program counter is incremented. This prepares the CPU for the next instruction. Decode is the second stage of the cycle. The control unit decodes the instruction in the CIR. The instruction is split into an opcode and an operand. The opcode identifies the operation to be performed. The operand identifies data or a memory address. The control unit generates control signals. These signals coordinate the CPU components. Execute is the final stage of the cycle. The control unit carries out the decoded instruction. Arithmetic and logic operations are performed by the ALU. Data movement instructions update registers or memory. Results may be stored in a register. They may also be written back to main memory. After execution, the cycle begins again. In summary, the CPU uses the fetch, decode, execute cycle to process instructions. Instructions are fetched from memory, decoded, and then executed. The cycle repeats continuously while a program is running. For the exam, program counter stores the address of the next instruction. MAR stores the memory address being accessed. MDR stores data or instructions from memory. CIR stores the current instruction being decoded or executed,